Tesla has developed a brand new electric motor, and the technology inside it is so advanced that it doesn't just outperform its competitors, it changes the way we think about what an electric car can do. But the most surprising part of this story isn't the motor itself. It's the reaction it received. The world's biggest car manufacturers, companies with decades of experience and billions invested in research, studied Tesla's design and then went completely silent. There were no press conferences, no promises of a better version coming soon. Just silence. If you're new to my channel, make sure to subscribe and don't forget to hit the bell icon so you never miss an update. So, what did Tesla actually create? And why has it left an entire industry speechless? Even Tesla's own engineers describe it as an incredible piece of engineering. They admit they've never seen an electric motor like it before. It's small enough to lift with your hands, yet powerful enough to launch a 2-ton car from 0 to 60 miles per hour in just 2 seconds. What makes the silence even more remarkable is that it goes against the unwritten rules of the auto industry. Normally, when a competitor introduces something groundbreaking, rivals respond immediately. They announce future products, promise improvements, and reassure customers that they're catching up. This time, none of that happened. There were no public responses or leaked plans for a comeback. Instead, engineers at rival companies carefully analyzed Tesla's design and came to a conclusion they didn't want to admit. The technology was far beyond what they expected, and they simply didn't know how to answer it. When experts have no answer, they stay quiet. These are not small companies. They are global automotive giants with some of the best engineering teams in the world. They usually have a response ready for every innovation. For them to say nothing at all wasn't confidence. It was the realization that Tesla had created something without an obvious solution. The engineers behind this motor speak about it with genuine disbelief. Despite its compact size, it can push a heavy 2-ton vehicle to 60 miles per hour in around 2 seconds. Even more impressive, it delivers power through a single-speed transmission all the way to nearly 200 miles per hour, without gear changes or any noticeable loss of performance. Even the people who built it seem slightly amazed by what they achieved. And that's what caught the industry's attention. If the creators themselves are surprised by their own invention, competitors have every reason to be concerned. But to understand why this breakthrough mattered so much, you have to look at where Tesla stood before unveiling it. At that time, Tesla wasn't an untouchable giant. The company was facing intense pressure while continuing to develop new technology, including an all-new battery pack and advanced carbon-sleeved motor rotors. For more than a decade, the world's largest automakers, Ford, General Motors, Toyota, and Volkswagen, had been locked in a fierce race to dominate the future of electric vehicles. Compared to these industry giants, Tesla still looked like an ambitious newcomer. Many believed it was only a matter of time before the established manufacturers caught up. So they invested heavily. Billions of dollars flowed into EV development. Thousands of engineers were hired, massive battery factories were built, and charging networks expanded rapidly. The competition genuinely improved, making better-looking cars with stronger batteries and better infrastructure. For a while, it seemed the gap between Tesla and everyone else was finally shrinking. Every few months, another startup claimed it had finally found the formula to beat Tesla. Headlines celebrated each newcomer as the next Tesla killer. The story seemed simple. Tesla had started the electric revolution, but now the established automakers, with bigger budgets, larger factories, and decades of experience, would eventually take over. That was the expectation. Then Tesla introduced this motor, and suddenly the conversation changed. That was the story almost everyone believed, until everything changed. What makes the next chapter so surprising is that Tesla didn't achieve this breakthrough from a position of strength. It happened while one of its most anticipated products, the Cybertruck, was struggling to meet expectations. For years, the Cybertruck was promoted as the future of pickup trucks. When Tesla first unveiled its futuristic stainless steel design, it instantly captured the world's attention. Its sharp edges, armored glass, and bold claims made it look more like a vehicle from a science fiction movie than something built for everyday roads. Millions watched the reveal, and excitement exploded. Pre-orders reached hundreds of thousands, and many believed Tesla was about to transform America's most popular vehicle category. But reality turned out very differently. Sales fell well below expectations. The vehicle that was supposed to redefine the pickup market attracted plenty of attention, but far fewer buyers than expected. People looked at it, talked about it, and shared it online, but interest didn't translate into strong demand. Some analysts who examined vehicle registration data even suggested that a noticeable percentage of Cybertrucks may have been purchased by companies connected to Elon Musk, including businesses like SpaceX, rather than independent customers. While those figures remain estimates rather than confirmed facts, they raised further questions about the true level of consumer demand. The Cybertruck wasn't the only challenge Tesla faced. When Tesla first entered the electric vehicle market, it had very little competition. That advantage no longer existed. Nearly every major automaker was now producing electric vehicles, giving customers more choices, lower prices, and making it much harder for Tesla to stand out. At the same time, recalls and quality concerns slowly began affecting the company's reputation. The picture was becoming clear. Slowing sales, growing skepticism, and increasing criticism from the media. Many commentators had already begun suggesting that Tesla's best days were behind it. Instead of asking whether Tesla would continue leading the industry, people were starting to ask how long its decline would last. This is where most companies become cautious. They reduce spending, scale back ambitious projects, and wait for better market conditions. Tesla chose the opposite approach. Rather than slowing down, it made one of the boldest decisions in its history. Why would a company facing so much pressure take its biggest risk at exactly that moment? Because what happened next completely changed the conversation. Instead of focusing only on selling more cars, Elon Musk pushed Tesla even further into artificial intelligence, robotics, autonomous driving, and self-driving vehicle networks. The Cybertruck may not have lived up to the enormous expectations surrounding it, but Tesla's next innovation would accomplish something much bigger. It didn't simply outperform competing technology. It challenged a belief the entire automotive industry had accepted for years. To understand why this new motor shocked so many engineers, you first have to understand one basic reality of electric vehicles. For decades, car manufacturers believed there was an unavoidable trade-off. An electric car could either deliver incredible speed and performance or maximize efficiency and driving range. Achieving both at the same time seemed impossible. A high-performance motor usually meant extra weight, more heat, greater energy consumption, and larger cooling systems. On the other hand, designing for maximum efficiency often resulted in slower, less exciting vehicles. The industry accepted this limitation as a fundamental law of engineering. Tesla refused to accept it. Its engineers searched for an entirely different solution. After years of development, they introduced an idea that sounds surprisingly simple, but was incredibly difficult to engineer. They wrapped the motor's spinning core, known as the rotor, with an ultra-strong layer of carbon fiber. That single innovation became the foundation of everything that followed. At the heart of every electric motor is a component called the rotor. As the motor runs, the rotor spins at incredible speeds. The faster it turns, the greater the centrifugal force trying to pull it apart. Push it beyond its limits, and the rotor begins to bend, weaken, and eventually fail. For decades, this physical limitation shaped the design of every electric motor. Instead of overcoming it, automakers simply accepted it and built their motors within those boundaries. Imagine swinging a bucket of water above your head with a rope. The faster it spins, the harder the rope pulls against your hand. Eventually, either the rope snaps or your grip fails. A rotor faces the same challenge, but at speeds far beyond anything a human could handle. Every second, enormous forces are trying to tear it apart. Traditional metal rotors can only withstand so much stress before they begin to deform. That limitation became the industry's accepted ceiling. Tesla decided to challenge that limit. Instead of relying only on metal, its engineers wrapped the rotor with carbon fiber, a material known for being incredibly strong while remaining extremely lightweight. The carbon fiber acts like a protective shell, holding the rotor tightly together and resisting the powerful forces trying to pull it apart. The concept sounds straightforward, but making it work was anything but simple. Carbon fiber and copper expand at different rates as temperatures rise. As the motor heats up, those materials naturally push against each other. To keep everything stable, the carbon fiber had to be wrapped around the rotor with extraordinary precision and extreme tension. The challenge was so difficult that no existing manufacturing machine could do it. So before Tesla could even build the rotor, it first had to invent a completely new machine capable of producing it. That alone shows how unusual this project was. Most companies would stop when they realized the necessary equipment didn't exist. Tesla chose to build the machine first and only then build the motor. That isn't a problem competitors can solve simply by spending more money. The result was remarkable. Tesla created a motor capable of spinning at more than 20,000 revolutions per minute, a speed normally found in specialized industrial equipment, not in a luxury sedan driven every day. At those speeds, even the tiniest manufacturing flaw could destroy the motor. The carbon fiber wrap is what allows the rotor to remain intact under such extreme conditions. But the real breakthrough wasn't just speed, it was stability. Even while spinning at extraordinary RPMs, the carbon fiber keeps the rotor balanced and controlled. That stability improves the motor's magnetic efficiency, allowing more electrical energy to become usable power instead of being wasted as heat. That single improvement changed what an electric vehicle could achieve. The motor delivered instant torque, breathtaking acceleration, excellent efficiency, a compact design, and lower cooling requirements, all at the same time. For years, engineers believed those advantages couldn't exist together in one vehicle. Tesla proved otherwise. The best demonstration of this technology was the Model S Plaid. It could accelerate from 0 to 60 miles per hour in under 2 seconds, outperforming exotic hypercars worth millions of dollars. Yet it remained a practical luxury sedan with room for a family and enough range for long-distance travel. That combination surprised the entire automotive world. Experienced journalists who had spent decades testing high-performance cars found themselves speechless after driving it. One full-throttle launch was enough to erase years of expectations. The same reaction spread throughout the industry. Reviewers struggled to describe the experience, while engineers at rival companies watched the performance with growing concern. Reading impressive numbers on a specification sheet is one thing. Watching a comfortable four-door family sedan outrun million-dollar supercars is something entirely different. At that point, it stopped being a debate and became undeniable proof. At that point, it was no longer just a claim, it was proof. You can argue with marketing, but you can't argue with a stopwatch. For years, the automotive industry convinced customers that real performance always required compromise. If you wanted speed, you had to sacrifice range. If you wanted efficiency, you had to accept lower performance. Then the Model S Plaid proved that both could exist in the same car. That's when Tesla's competitors truly fell silent. No press conference or marketing campaign could change the laws of physics, and Tesla had just shown that the old limits weren't as fixed as everyone believed. But the motor itself wasn't the biggest reason the industry became concerned. The real advantage went much deeper. Many companies can build an impressive prototype. They unveil a futuristic concept, attract investors, dominate headlines for a few days, and generate excitement. But building a few showcase vehicles is completely different from producing millions of them efficiently and profitably. That's where most companies struggle, and that's where Tesla built its biggest lead. What many people overlook is that designing one advanced electric vehicle is only half the battle. The real challenge is manufacturing millions of identical vehicles at high quality, low cost, and a sustainable profit. Tesla understood this earlier than most of its competitors. While other automakers focused on flashy product launches and advertising, Tesla spent years solving difficult manufacturing problems behind the scenes. Those years weren't exciting, but they created an advantage that is becoming increasingly difficult to match. Tesla's latest drive units weren't designed only for speed or efficiency. They were engineered from the beginning to be easy and affordable to manufacture at massive scale. That may sound ordinary, but it's one of the company's biggest strengths. Most engineers focus on achieving the highest performance numbers. Tesla focused on building technology that could also be mass-produced efficiently. Instead of creating a breakthrough first and worrying about manufacturing later, Tesla developed both at the same time. That decision changed everything. The company's long-term goal is equally ambitious. Tesla wants complete drive units, including the motor, power electronics, and gearbox, to cost roughly $1,000 to manufacture. For the rest of the industry, that target was shocking. Many competing systems cost several times more while delivering similar performance. That difference isn't just significant, it completely changes the economics of building electric vehicles. Imagine spending your career trying to reduce production costs by a few dollars at a time, only to see a competitor announce a manufacturing cost that's a fraction of your own. There's no simple adjustment that closes that gap. No supplier negotiation. No accounting trick. If you can't explain how your competitor achieved those numbers, you also can't explain how your company plans to catch up. That's the challenge many traditional automakers now face. What makes it even harder is that there's no shortcut or hidden secret to expose. Tesla didn't rely on cheating or luck. It simply invested years solving problems that other companies avoided, and that's not something competitors can easily copy. Reverse engineering the motor itself is possible. Engineers can take it apart, measure every component, and understand how it works. But that still doesn't give them Tesla's real advantage. The breakthrough isn't only in the hardware. It's hidden inside thousands of manufacturing decisions, how each part is designed, sourced, assembled, tooled, tested, and produced at massive scale without driving costs higher. Those lessons can't be discovered by taking apart a finished motor. They come from years of trial, error, and continuous improvement. That's exactly why even the industry's toughest critics, people who make a living tearing cars apart and analyzing every bolt and component, recognize that Tesla's advantage goes far beyond what can be seen on the surface. Sandy Munro built his reputation by being one of the toughest automotive critics in the industry. For decades, he became known as someone who was rarely impressed by new vehicles or engineering claims. But when he and other teardown experts examined Tesla's drive technology, something unusual happened. Instead of their usual list of criticisms, they responded with genuine respect and even a sense of surprise. The people whose job is to find weaknesses were struggling to find any. What worried the rest of the industry wasn't simply how good Tesla's motor was, it was how difficult it would be to copy. Some experts believe competitors could spend years, possibly close to a decade, trying to catch up. By the time they did, Tesla would likely have moved on to its next breakthrough. That's what makes this so important. Teardown experts aren't influenced by advertising or hype. Their reputation depends on judging products based only on engineering. So when even the harshest critics acknowledge a design without major criticism, that carries more weight than any marketing campaign ever could. They weren't convinced by presentations. They were convinced by what they held in their hands. Meanwhile, Tesla isn't standing still. The company continues improving its motors by reducing the use of rare earth materials, lowering its dependence on expensive supply chains. At the same time, it's redesigning its power electronics to use less costly materials while maintaining high efficiency. This creates a powerful cycle that becomes harder to stop every year. Every manufacturing improvement reduces production costs. Lower costs allow Tesla to lower vehicle prices. Lower prices attract more customers. More customers increase production. Higher production gives Tesla more manufacturing experience, and that experience leads to even lower costs. The cycle repeats itself again and again. That self-reinforcing loop is Tesla's real advantage. You can reverse engineer a finished product, but you can't reverse engineer years of manufacturing experience, failed experiments, and production improvements that made it affordable in the first place. That's why competitors continue struggling. Ford introduced impressive electric vehicles like the Mustang Mach-E and the F-150 Lightning. Yet its EV division reportedly lost billions of dollars. Lucid built technologically advanced luxury cars, but continued burning through cash. Rivian attracted enormous investment, but still faced extremely high production costs. Even companies like General Motors and Volkswagen dealt with software delays, manufacturing setbacks, and ongoing concerns about profitability. Among major competitors, only BYD appears capable of challenging Tesla on production scale, especially in lower-cost markets. But BYD's biggest strength is affordability. Tesla is aiming for something much more difficult, building some of the world's most advanced electric vehicles while also making them inexpensive to manufacture. That combination is what truly worries the industry. Yet even that doesn't tell the whole story. Tesla's greatest advantage isn't just its motor. It isn't even its factories. It's the way every part of the company works together as one connected system. Many people still think Tesla is simply a car manufacturer. In reality, it operates much more like a technology company that happens to build cars. Its vehicles, software, manufacturing, artificial intelligence, and data collection all reinforce one another. The clearest example is data. Every Tesla on the road continuously collects real-world driving information. Every mile driven teaches the company more about traffic, weather, road conditions, driver behavior, and the countless unexpected situations that autonomous driving systems must learn to handle. What makes this data so valuable isn't only the amount, it's the variety. A Tesla driving through Norway learns how to handle snow, ice, and long winter nights. A Tesla in Arizona gathers experience in extreme heat and intense sunlight. A Tesla navigating Mumbai encounters traffic patterns unlike anywhere else in the world. Every unusual intersection, construction zone, and unexpected event becomes another lesson that improves the system. No competitor can recreate that simply by testing a few hundred vehicles on closed tracks. Real-world driving is unpredictable, and Tesla has been collecting those unpredictable experiences every day for more than a decade. Its advantage continues growing automatically. Every second, millions of Teslas are gathering new information without the company needing to send out dedicated test vehicles. While many competitors are still expanding small testing fleets, Tesla's existing vehicles have already experienced millions of unique driving situations that may never happen exactly the same way again. That's why competing with Tesla isn't only a race against another company, it's a race against time. And right now, time is working in Tesla's favor. No competitor can buy this advantage overnight. It can only be earned through years of real-world driving, millions of vehicles on the road, and billions of miles of collected experience. A company entering the race today isn't just behind. It falls further behind every single day because Tesla's fleet keeps growing while others are still trying to catch up. And that's only part of the story. Tesla has invested billions in developing its own battery technology because batteries are the most expensive part of any electric vehicle. While many automakers still rely heavily on outside suppliers, Tesla designs much of its own software, computer chips, and power electronics. That strategy proved especially valuable during the global semiconductor shortage. While much of the auto industry struggled, Tesla quickly rewrote its software to work with available chips, allowing production to continue with far fewer disruptions. Its factories reflect the same philosophy. Facilities in Fremont, Shanghai, Berlin, and Austin are more than manufacturing plants. Tesla treats each factory as a testing ground, constantly improving how vehicles are built. Every new factory learns from the previous one, making production faster, cheaper, and more efficient. The real challenge for competitors is that none of Tesla's advantages exist on their own. A rival might eventually match the batteries. Another might improve its software. Others could expand manufacturing or develop better AI. But matching every one of those strengths at the same time is an entirely different challenge, especially while Tesla continues improving all of them simultaneously. It's like trying to beat someone in several different sports at once while they keep getting better every single day. Then there's another advantage many people underestimated for years: Tesla's Supercharger network. At first, critics treated it as nothing more than a convenient bonus. Over time, it became one of Tesla's strongest competitive advantages. The network is fast, reliable, and widely available. Meanwhile, many competing charging networks struggled with broken chargers, confusing payment systems, and inconsistent performance. Eventually, something remarkable happened. Companies like Ford and General Motors adopted Tesla's charging standard so their own customers could use Tesla's charging network. Think about what that means. Automakers with over a century of history looked at the problem, compared their own charging systems with Tesla's, and decided the smartest solution was to adopt Tesla's technology instead of competing with it. Soon, other manufacturers followed the same path. Today, many Tesla competitors depend on Tesla's infrastructure to provide a better charging experience for their own customers. Every time one of those vehicles plugs into a Tesla Supercharger, Tesla earns revenue. That's more than a competitive advantage. It means Tesla has become part of the foundation the rest of the industry now relies on. Imagine trying to sell a new electric vehicle while telling customers it has fewer charging options than a Tesla. For many companies, that simply wasn't acceptable. The numbers made the decision for them. This is why Tesla's new motor created such a powerful reaction. It wasn't just an impressive piece of engineering, it was another advantage added to an already powerful system. Today, Tesla isn't competing only in electric vehicles. It's competing across batteries, software, artificial intelligence, manufacturing, autonomous driving, charging infrastructure, real-world driving data, and global production. A competitor might spend years catching up in one of those areas. Catching up in all of them at once is a completely different challenge, especially because Tesla isn't standing still. Every year competitors spend closing the gap is another year Tesla spends moving even further ahead. That's the real reason the industry became so quiet. It was never only about the motor. The carbon fiber rotor wasn't the biggest breakthrough. The real breakthrough was the system that made it possible. A system capable of producing new innovations faster than competitors can copy the old ones. Engineers across the industry weren't simply looking at a better motor, they were looking at an engineering ecosystem that's incredibly difficult to replicate. And that's not something a press conference can solve. The electric vehicle revolution is happening, but it may not unfold the way many people expected. Instead of a market where every company moves at the same pace, we may be watching one company build an integrated technology platform while everyone else works to catch up. So, what do you think about Tesla's latest breakthrough? Do you believe its competitors will eventually catch up, or has Tesla already built too large of a lead? Share your thoughts in the comments below. We read every single one. And if this video gave you a new perspective on Tesla, hit that like button and subscribe so you don't miss what's coming next.